Hello, thank you for joining this session of DPS Data Platform Summit 2020 virtual. This session is about Power BI for ticketing and subscription system. We are going to talk about some of the ways that you can have ticketing and subscription system analyzed in Power BI. Now, we are not talking about all the different metrics of such a system. We are talking about some of the important metrics, however. Before we start, a little bit about me. I'm Reza Rad. I'm a Power BI consultant. I'm a Microsoft Regional Director and MVP for over 10 years now. I have written some books on Power BI and some books on SQL Server before that. You'll find the links to them in our blog. I'm also an active blogger. And I have YouTube videos. There are lots of free materials in Redicat website for you to study about Power BI. If you have any questions about Power BI later on, feel free to reach out to me and ask your questions. Now, what this session is about. The agenda is quite simple. We are going to have a quick overview on what Power BI relationships is. We'll talk about some of the modeling principles of how to create a star schema, because those are the basis of any design pattern. Then we go and talk about calculations in DAX, how that can be helpful in a scenarios of having a snapshot fact table scenario, which is one of the scenarios for a ticketing and subscription system. And we'll talk about calculations such as active subscription calculations, some other calculations related to that, such as customer retention, churn rate, and anything related to that. So let's have a look at that, starting with the relationship. Now, this part I'm going through that quicker than my normal pace, because this is not a basic session, but it is important to understand these basics. What is a relationship in Power BI? In Power BI Visual, when you have like two fields coming from one table, one of them used as an axis, another used as a value, this normally works fine. The field that is used as an axis is normally filters the field that used as a value. Here, for example, count of records, basically. It is saying count of store ID, but it can be count of anything else. Is the value, the axis here, the filter criteria is the state. So what happens behind the scene is that the table gets filtered for every state. For example, for a state of Washington, we'll have like 2 stores. For California, we have 3, and for Oregon, we have 1. Right? It works really simple, and it can work in other table scenarios as well. So here I have another table which I'm using a store ID as a filter, and quantity is the value. So for each store ID, we have sum of the value of the quantity showed over here. Everything is normally fine as long as you don't have a relationship. But as soon as you bring a relationship into Power BI, then as soon as you bring the second table in Power BI, then things get sometimes a little bit strange. For example, here I have state from the stores table and quantity from the sales table. When I have them in one visual, like the visual that you see in the right hand side here, that is state and quantity. You see the quantity is the same for all of these. So it doesn't really get filtered. There is a way, however, to get these two tables filtering each other. State is in another table, quantity is another table, but these two tables can talk with each other based on the store ID. The field that you see is highlighted with using that red square around it. So that means that in Power BI we can actually create kind of a relationship. In Excel or some other tools we create this with lookup, or in SQL Server or any other data platform based technologies as well. Now in Power BI we create that as a relationship. So relationship in Power BI means that this table, this field, can now filter this table, this field, and of course any other fields, because as soon as this filters this will filter the entire row. So as a result, it would filter that. So that would mean that our store table can actually filter the other table, which is the orders table. And as a result, even if I have fields in my visualizations which are not actually store IDs, they are not the fields that I used in my relationship, still this works, because as soon as I select a state, let's say for example Oregon, this will find out what is the store ID for that, 8042, and that means this table will also get filtered for 8042, and then I get sum of quantity for that store. And this is a process that happens for every one of these rows. This is how the relationship works. Now, relationship have some properties. One of them is cardinality of the relationship. Cardinality of a relationship means that means these numbers you see on the two sides of relationship. If you are coming from database background, this is kind of familiar concept for you. This is saying that how many of those values we have in that table. For example, if I'm connecting these two tables based on a store ID, in this table, the stores table, which is like 6 rows in total, the unique number of store ID is also 6. So store ID is kind of identifier for this table. It's a key for this table. It's actually a primary key for this table, because with one store number, you can only find one single record in this table. That's quite important. And in the other table, however, you can have multiple records with that store ID, which of course this means that this, let's say there has been multiple sales order from that store. Now, if we create a relationship between these two tables, that would be a one-to-many relationship from the store table to the orders table. There are other types of relationships as well, many-to-one. Many-to-one and one-to-many are the same. It's just a matter of which way you read it. These are the two most common type of relationship. One-to-one relationship is normally a type of relationship that we normally merge tables in Power BI to get that. And then finally, many-to-many relationship, which normally I don't advise it, because it leaves the space for like creating like a reference tables. I would suggest creating dimension table and reference tables. As I said, I'm not going into the details, I'm just keeping it high level for now. Another property of the relationship is active or inactive. Now, everything since now, you might have used it in other technologies using data such as SQL Server, Oracle, but this is specifically for Power BI. In Power BI, you can have only one active relationship between two tables. This means that the date table can only filter the sales table in one way. You cannot filter it in two ways. You cannot say this will filter the sales table on the ship date and also on the order date. This is not possible, because which one is actually the value that is filtering, right? So that means that the second relationship or the third relationship or fourth relationship, any more relationships you add to the table, they all would be inactive. Normally inactive relationship is like dashed line, as you see here. Now, inactive relationship doesn't really do anything in Power BI unless you go and write a specific measure, a specific calculation to use it. There's a measure called, there's a function in DAX called use relationship. You can use that in a measure, and using that you would use that calculation. Another approach is to create something in BI terminology. We call it a role-playing dimension, a dimension that plays role of multiple dimensions. So here, for example, you see that I have the date table that connected to the sales table probably by order date key, but then I have a copy of that date table called ship date table that is connected based on the ship date key. Using it this way will avoid creation of an inactive relationship, and as a result everything would work fine. However, you would need to create extra tables. Now, the choice between creating role-playing dimension or doing inactive relationship and having a DAX measure for that is mainly depends on the size and how many of these tables you are going to create. For example, if I'm going to create role-playing dimension for date tables, those are normally fine, because date table, it's like 365 records per year for 20 years. This is like 7,000 rows. It's such a small table. Even if you create like 10, 15, 20 of these tables, that's not a big deal. But if you do it for a huge table, let's say you have a product table, customer table that is like over 10 million rows. For those scenarios, I would suggest keep that relationship inactive and write a measure to cover that. One last thing about relationships, and then we'll talk about the next subject, is the direction of relationship. This is again very important, unique only to Power BI. You won't see that in the database, in the, let's say, SQL Server database or RDBMS. Normally you won't see that, and that is the direction of relationship. For example, in SQL Server, when you create a relationship between two tables, or when you create a join or whatever, it's like, it doesn't really have a direction. But here, actually, direction matters. The direction of relationship means what way the filter actually propagates. Now, if I have a model like this, if I have dim product, dim customer, and fact internet sales, and dim customer filters dim product, fact internet sales, that is the meaning of this relationship. Dim product filters fact internet sales, and that is the meaning of this relationship. Normally, this works all perfectly fine. Nothing is wrong about this kind of relationship direction. That means you can select a product, or the color of product, or the size of product, whatever product attribute you want to use, and that will get filtered all the measures you have in your sales fact table, such as sales amount, quantity of orders, and things like that. Same between customer table and fact internet sales table. The situation, however, can be a little bit challenging when you want to filter another dimension by this dimension. For example, if I want to get count of products from the product table, then because this table filters the other table, but in a normal situation, this is the product table that filters the fact internet sales table, not the other way around, then you need to come up and change that relationship to become both directional. Both directional relationship is not a really good relationship in Power BI. I highly recommend you to not do it. That would impact the performance of your model. This will introduce ambiguity in your model. It will make your model performing really slow, and you would have a lot of challenges from that point onward, for like probably you'll need later on to make that relationship both directional, another relationship both directional, and that would be a chaos in terms of both performance and ambiguity of your model. It would be so confusing. What I would suggest is to bring your values from your fact table. For example, if I want count of products, I would be able to get it using a distinct count from the sales table itself. Now, it's not something that you can always fix it that easy. Sometimes you need to change your model a little bit. Sometimes you need to bring some of the new measures and calculations into the fact table. And there are also some scenarios that no matter what you do, at the end of the day, you need a both directional relationship, which in those cases I would suggest using a DAX measure alternative for that. That means keep the relationship like single directional, but then use a DAX measure with a function called cross filter. Inside calculate, you will use it, and that will give you a calculation based on both directional relationship, which would be only for that calculation. That would be much better than making that relationship both directional. Okay, so wrap up on the relationship parts. So for the relationships, many-to-many relationship is something that I won't avoid. Both directional relation that I would avoid, I said. So no many-to-many relationship. Both directional relationship the same. Don't create it. Inactive relationship is not wrong, really. You can use it, but make sure that if you use it with use relationship function. If you don't use it, use the role-playing dimension scenario. Now, another important subject before talking about design pattern is that is about dimensional modeling. Now, if you are coming from BI and data warehouse background, you might have been familiar with this subject. Dimensional modeling is saying that we need different layout than what we have in the data source. For example, you might connect to a SQL Server database. You might have like 200, 250, 1,000 tables in a database. If you connect to CRM database or Dynamics AX, you will actually see that many tables, sometimes over 1,000 tables. You shouldn't just load that as is into Power BI. You need a different layout. Why do you need a different layout? Because there are two types of tables based on what you have seen in the relationship. There are tables that can be used as a slicer. They can filter other tables, and there are tables that can be used as a value in a visual. For example, in a line chart, you can have a table, a field from a table showing as a value, a field from a table showing as an axis. These are different tables. That means you need a different types of diagram than what you have already in your source table, in your source database. Now, for example, if I look at diagrams, the visuals here, I can see that the sales amount is the value showed here, but it is sliced and diced by birth date. These are basically years of birth date. Or the other one is yearly income. It's actually sales amount again, but it is sliced and diced by yearly income, which is a value down there. So this explains that whatever table you have that is explaining something, they are descriptive information. These tables are separate table. We call them dimension table. A dimension table has these descriptive values in it, and normally it is used in slicers, in filters, in axes, or a legend of a chart. And descriptive means text, but it also means date and time value. It also means for example, a number value. Here, for example, you see yearly income, right? Dimension tables normally have a lot of columns. The reason is that, like, the more columns you have, the more power you will have in the slicing and dicing, but they are shallow. That means you don't really have that many rows in these tables compared to what you have in your fact tables. These are examples of dimension tables: customer table, product table, promotion table, and each dimension table has like different fields explaining that. For example, for customer, first name, last name, education, occupation, things like that. Fact table, on the other hand side, is a table that that actually has a record for happening of an action. For example, if you are doing a sales analysis, one of your fact tables would be the actual sales transactions. That is a fact table, and it will keep one record per transaction. Now, normally a fact table keeps like some numeric information such as order quantity, unit price, cost, sales amount, and things like that, but it also have relationships to the dimensions around it, and the level of details you store in a fact table defines something. We call it as a grain of a fact table. So fact table basically includes numeric values, numeric fields. We call them facts. These are aggregatable fields. Sometimes you aggregate them, sometimes you look at individual values, and key fields from the dimension tables. This means that this fact table is connected to product table, date table, and customer table. The grain of a fact table is the level of details we store in a fact table. Here, for example, you see that the fact table at the top has one record per product, per order date, per customer. The second fact table has one record per product, per order date, per customer, and per promotion and per sales territory. Normally, the more dimensions you add to the grain, your fact table would be more detailed. That means you have much more rows into that fact table. So at the end of the day, the relationship between your dimensions and fact tables are something like this. Your dimensions would filter your fact table with the one-to-many relationship. As you can see here, right here, I have my product table, sales territory table, and customer table, and dim date table. They are all filtering one-to-many relationship, no bidirectional, all single directional. And that creates something, we call it a star schema. How this is a star schema? The fact table is kind of like a heart of the star, and these dimensions are points of that star. It can be as many as dimensions you want. Sometimes you have one fact table with only one dimension. Sometimes you have one fact table with 2 dimensions, 3 dimensions, 10 dimensions. That depends on how the scenario is. If you have dimension to dimension relationship, that is not a good scenario for star schema. This is not what we call as a star schema. Extra relationships would bring, again, confusion into the model. It would slow down the performance as well. Depends on the size of dimension. This might not be a big performance, it might be a small, or it might be a big. So it's always better if you have dimension to dimension relationship. Think about your modeling again. In most of the time you might be able to combine them into one dimension. Here, for example, product category, subcategory, and product, they are all product attributes. So I can combine them using merge in Power Query, or if you are using SQL, using joins in SQL, and then load it into Power BI. That would be one dimension, then filtering the fact table, not dimension to dimension filtering. A dimension to dimension relationship would cause creation of a snowflake schema, which is opposite of the star schema. You should try to keep your model as a star schema. And the star schema doesn't mean just one fact table. You can have multiple fact tables, as you can see here. And each fact table has relationship to their related dimensions. I have an article about multiple fact tables, like a budget versus actual scenario using star schema and Power BI. And there's a link at the end of the slide deck. You can go and check it out. Okay, now that we talked about star schema, now it's time to talk about design pattern. So we are talking about ticketing and subscription design pattern in this session. Now, what is a design pattern? A design pattern is actually kind of like pre-built model. It's basically, it can be like a Power BI file with some tables, relationships to each other. Now that doesn't mean that you just connect it, you just download it and connect it to your database and everything would work. No, it's not like that. It's basically show you how this is done. So it shows you that, for example, in a ticketing system, these are, for example, dimensions you might have. These are fact tables you might have. This is how they are related to each other. These are types of calculations you need. Now, when you go and use it in your system, you don't have to rewrite those calculations. You don't have to rethink of how you need to create that star schema. You have a model that you can adjust things based on that. You might need to adjust your calculation a little bit to fit into that formula. Your field names might be different, your tables might be different, but you can adjust it based on that. That is what the design pattern is. So it's more like something like a gold model that you can use as a sample to build a Power BI report faster. It helps you a lot in creating your report much faster. Now, the design pattern we are talking about in this part is a subscription pattern. I have a Power BI report which I'm going to open in a second so that we can have a look at that. Now, this Power BI report I'm going to look at is actually a sample Power BI file, so it doesn't have, let's say, that many records in it, but the fact is that you can use it in any other scenarios and you'll get the same outcome as well. So waiting for this Power BI file to open. Now, yep, here it is. So Power BI file is getting opened. I have basically just few tables here. I have a customer table. This is like a customer dimension based on what you learned. This is a descriptive information about customer. It has an ID because I use this ID to then join it with another table. I also have a date table, and the date table has like one record per day, and I have also a subscription table. The subscription table, or in scenarios of ticketing, this would be basically ticketing table. What it says is that this is the subscription number, this is the start of the subscription, end of the subscription, and which customer this relates to. So this is going to be actually related to my customer table over here, right? So this is going to be my customer table. And of course I have my date table, my date fields here. So what this actually means is that, for example, if I have a subscription like subscription number 3, this is started at 12th of August 2019, finished at 14th of February 2020. This is a subscription that has been active during that period, but it's not anymore. But for something like subscription number 6, this has been active since 20 June 2019. Because there is no end date, this is not finished yet. Now, in some systems, you might have some other things here saying NA not applicable or having a far end date. Depends on how your system is implemented. You might have a different things, but normally you have a way of identifying that there is no end for this at the moment this is active, right? In a scenario like this, one of the most important metrics in a subscription system, and this could be ticketing as well, like for example, if it is ticketing, this would be like the date time that this ticket has been opened or when it is closed, right? Or you might have more stages than that, which can be covered with more columns. So let's say in this ticketing or subscription system, it is important that we have a chart that tells us, like at the bottom here, we have date, right? And it tells us that at each date, like how many active subscribers we have, like this month that much, this month that much. So it tells us like how many active subscribers we have by date, by month, by quarter, and anything like that, right? Now this chart might be a column chart, this might be a line chart, that doesn't really matter. The main thing that matters here is how to analyze such information. So this might look simple at the beginning because you think, well, I have the date, I bring the date in my visual and I start showing basically the count of records here. This could be count of subscription number or count of any other fields, right? But the problem is that if you are going to bring date into your visual, which date you are going to bring in the visual? Like we have two date fields here, right? So you might say, considering that what you have learned about the concept of having a star schema, you might say, well, we do have a date table, right? That's correct. We do have a date table. Let's say this is my date table. But then this date table is connected to which? Is it connected to this or is it connected to that? Or is it connected to one of these active relationship, the other one inactive relationship? Or do I have like one date table for end date, one date table for start date? Let's say we did it for that. We did one for start date, one for end date as role-playing dimensions. But again, the challenge is that the date field is coming from which date table down here? So let's say you decided to have the date field coming from start date, or let's say the table that is connected to your start date, the date field of that comes here. Now that visual is not really showing you the active subscribers for every day. That visual is showing you how many subscriptions have been created, opened, started that day, or how many tickets have started that day. It doesn't tell you if you have a subscription that has been started yesterday, but it is still active today. That won't tell you that. And if you bring the one that is coming from end date, that would not again tell you how many active subscriptions you have a day. It just tells you how many subscriptions you have which has ended at that day, right? So in fact, none of these are actually helpful, right? I cannot rely on these to be my my axis here, not in this visual directly. I have to use them a little bit differently. So what you should be doing normally is to create like a different type of table, right? So I'm going to show you something like this. I need to create a table like this. I need to have a table. That table, in that table, I have a column which is date, right? And I have, let's say, another column here which is active subscribers, right? Now this table should have one record per day. Let's say this is 1st of January, 2nd of January, 3rd of January. And what we do in a table like this is that for every day, we calculate how many active subscribers we have. Like, for example, for 1st of January, let's say we have 2. For 2nd of January, we have 3. For 3rd of January, one of them actually unsubscribed, but we have 2 more subscriptions, so this is still 4, something like that, right? So it changes like that, right? This is a table, we call it a snapshot fact table. Some people call it periodic snapshot fact table because you have a period here. In our case, the period is like daily. Some people just call it snapshot fact table. It's the same thing. A snapshot fact table is a table that has one record per the detailed period that you want, but also it has one record per combination of other fields that you might have in your scenario. For example, this is giving me the total, right? What if I want to select a customer and see if that customer has been active in a date or not, right? So that means I need to have also a customer key here, right? And then that means for every customer, for every day, I need to have a record, right? So if this is for customer X, then 1st of January, I need for customer Y. 1st of January, I need that for customer W. And then I need the 2nd of January for XYW, 3rd of January for XYW, right? Now, this can get quite complicated. What if I also have a product column, right? Let's say, what if I also have a product column here? Then that would be also cross-join of these. What I'm trying to say in this example is that snapshot fact tables are good for calculating things at that point of the time. But the problem with these tables are that these are huge tables. These are the biggest tables normally you can find in a data warehouse. And the reason is exactly that cross join of these. Like, for example, if I'm creating a snapshot fact table, just to give you an idea, on a daily basis, right? Let's say I'm creating a snapshot fact table for every day, right? 365 records per day. And I'm creating that for 20 years, right? So that is this many rows already. Now I'm doing that for the number of customers, and I might have, let's say, 20,000 customers I might have, right? And I have not just, let's say, one product for subscriptions, and you can consider it ticketing as well, right? This could be ticketing. You do not have ticket for one purpose only. Ticket might have, in different cases, different purposes. So let's say we have different variations of that, like 20 of those variations. You see how this can adds up? And this is just like 4 fields I added. What if I add another variation? This is already something close to 3 billion records in a table like that, right? Now, I'm not saying that Power BI cannot handle this. Power BI definitely can handle like petabytes of data. There is no problem with that. What I'm saying that is, if you are creating a table like this, just for the purpose of some of those calculations, there are better ways to do that in Power BI. One of those ways is to leverage DAX calculations that we can use to have a better analysis, dynamic analysis on many things. For example, we can use DAX to be able to look at every single day and see how many active subscribers we have on that day. Now, I'm not saying that whenever you see a snapshot fact table, go and replace it with DAX. That is really depends on the scenario. Sometimes you need a snapshot table which might be aggregated on a monthly level, quarterly level, so it might not be really a big snapshot fact table. And you might have, let's say, 40 different metrics to calculate. In those cases, you might just keep it as a snapshot fact table. In some other cases, this is a really detailed snapshot fact table, and you just have 1 or 2 metrics to calculate. So in those cases, I would do it as a DAX calculation. So let's have a look at how we can do this as a DAX calculation if we want to do it. Well, I'll show you the DAX expression, but I'll go through some explanation of how this works. So here I have just one measure. A measure in Power BI is a dynamic calculation. This is how the measure is created. Now I'm going to explain that step by step. So In a Power BI measure, which is written in DAX formula, you can define variables. So here I have defined a variable. A variable is a temporary storage for something I want to use later in my code. For example, I created this, stored it as a variable, then I used that later in my code, right? Now, this means that my code would have worked even without a variable, but I created the variable just to make it more readable and sometimes performing faster as well. Variables are quite good with that. In the variable, you can store a single value or you can store a whole table. Now, here I have used this function, selected value, which tells me what the date is. Now, before talking about this, let me explain how the design of my diagram is. So let's go to the diagram design. I have just 3 tables, as you see already, right? But the fact is that my date table is not connected to any of these tables. It is not connected to the end date. It is not connected to the start date. This is the important part of designing the model like this way. Why it is not connected? Because you already seen that it won't be a point if I create a visual with having a start date at the bottom, or if I create a visual with having end date at the bottom as an axis, unless this is really one of the metrics you want, unless you really want to have a visual showing all subscriptions that have started at each day or ended at each day. That might be something to create. In that case, go ahead and create like role-playing dimensions of this and create the relationships. In this case, I'm just focusing on active relationships, right? So if I'm focusing on active relationships, there is no point of creating this relationship, because if I create this relationship, this would automatically filter that table. As a result, I would see only records that have been started or ended at that date, right? That active relationship between this would only work if I have the snapshot fact table, which I'm not going to do that, right? So I'm going to my calculation now. So what that selected value of the date table means, that means I can find out what date value is in the axis of a chart I'm looking at. For example, if I have a chart like this, right? If I have a chart like this, for every value here, there's a date, right? You can see when I move it around, there's a date. Now this tells me which date it is. That is what the selected date, selected value function does, right? So I keep it somewhere, right? I also keep the minimum start date. I'll talk about this part later. For now, don't worry about that. Now I have another variable that gives me list of subscribers. Now this is a table variable. You can easily use a table inside a variable. It's a concept of like virtual table. You create a table, but this table doesn't really exist as an actual table in your model. It's a virtual table just created within that measure. Then after the measure is calculated, that table is kind of like vanished, doesn't exist anymore. But it helps in dynamic generation of that. So I'm creating a list of subscribers. What is this list of subscribers? It is the filtered result of the subscription table, the table that I have all of these subscriptions with these criteria. First, I want to find out all of those who are still subscribers. Well, that means those that their end date is blank. So their end date in the subscription table is blank. Those are still subscribers. No matter what date I'm looking at, if their end date is blank, then they are still subscribers, right? And there's a point about that. We'll talk about it later. Or, this means or in DAX, or you can type or function itself. Or their end date is after the date we have in our visual. Now, let's say the date that we have in our visual is 2nd of June 2020, right? So 2nd of June 2020, if the subscription end date is 5 of June 2020, this means that this was active at the date of 2nd of June 2020. Right? So it was active at that date. It is not anymore, right? But it was active at that date, right? It is not active now because it has an end date, but it was active at that date because it is greater than or equal that date. Now these two would only work if the subscription has started before that date. Again, if that date is 2nd of June 2020, if my subscription end date is blank, but this actually has created after June, let's say this is someone subscribed in August, I shouldn't count that person as an active subscriber in 2nd of June, because that person was not exist there, right? Or that subscription wasn't exist there. So that is why after those two, I just add an and. These two again means and. I would say only when the start date is before or at the same date of that selected value. So this is actually kind of creating the relationship between date table and my subscription table, but kind of virtually, right? So using this approach of comparing the date fields in my subscription table or in fact table, comparing it with the date coming from another table, even if there is no relationship between them, I kind of create that relationship virtually customized based on whatever I want. So this filtered result now would be all records from the subscription table that are active subscribers based on these criteria. Then I just have one other variable saying that give me the count rows of those. That will be give me the count rows of that table. You can use a variable inside another variable. So I created that. So this would be basically count of active subscribers. However, there is still something else at the end of returning the value from this measure, and you see there's an if statement. The reason for that if statement is that if because now the date table and the fact table, they have no relationship at all, right? I've created that relationship kind of virtually. If I use the date field from that date table in my visual, that might go back all the way on, let's say, from 1990. But subscription, let's say, started from 2000, right? So I'm saying that only do it when the date that we have in a visual is actually after the very first date that we had any subscriptions. And that is where I use this measure, saying that the minimum subscription start date. So only do it after the very first day of subscription and before today's, because there's no point showing these values after today. This is a way that I can actually control it and have it within a range. So if it is within that range, and if I don't have a blank value for count of rows of subscribers, then just show it. That is all of the expression. Now let me show you how this works. So here you can see this is the date that I have from my date table. The measure value showed in this chart. This is a normal area chart, nothing really complicated about this. And it gives me that number at every given day, right? So without having that table of snapshot values, I've created that somehow. So here you can see actually that kind of snapshot table for 20th of January. It shows me the value 21st of January, 22nd of January. But in fact, I didn't create that table. This is all created by that DAX calculation on the fly because I have this measure. So at any given date, this tells me how many active subscribers I have. And as soon as this starts adding up, which should be somewhere in this case, June, 18th of June, I think 19 will get something. So if I go a little bit further, I see the point that we have the second subscriber, and adding for some scenarios, this is going down, up, down, and up, right? These values are small because I have a small table to go through. Remember, it was just like 4, 5, 6 rows altogether. Now, one benefit of doing it using that calculation is that now you can even do this analysis by customer. You can select a customer and find out how their process was. For example, for this customer, I see that this has been an active subscriber and still is an active subscriber. Again, think of this such as like tickets as well. It's still open ticket. Or for example, for this is not it's closed. Or some other scenarios, closed and open again, right? It calculates all of those. So quite useful analysis. I can even filter by date and look at all the calculations within that period. So everything really works quite dynamically without me needing to create such a big table. If I would have created such a big table, this file would have been like so big. Now this file is just 140K. You can download these files, by the way, from my blogs, and there's a link down at the slide deck. You can use that to download this file. This is like 140K file. Now, if I had a snapshot fact table, this might have been like hundreds of megabytes of file, and every time I open it, my system might have had a lot of things to look at, a lot of resource consumptions and things like that. Then I need to do a lot of like performance consideration to make sure that this is working properly, where compared to this approach, I just created a calculation just like this and it worked, right? Now, in a subscription pattern, another important metrics is about customer retention, which I'm going to show you that in another Power BI file. Now, customer retention is talking about how many customers I have are new, how many of them are, let's say, returning customers. Retention actually means those who are returning. Churn means those who are lost customers. And new customers are, of course, new customers. Now, the ideal scenario would be for me to have something like this, to see at every period. This could be quarter, this could be month, this could be, let's say, day, whatever period you want to analyze it. And you can adjust that period as well and say, for example, how many active subscribers I have, how many let's say new customers I have. These customers, the customer retention can work with subscription, or it can work individually as well. I can choose, for example, all of those customers who have not purchased anything from me in the last 5 periods. They are like lost customers, so I can customize that, and this calculation changes based on that. Right. For example, if I say those who haven't purchased in the last 2 months, I will have much more lost customers. If I change it to become much more, then I would have really low lost customers, but a lot of like new customers and some returning customers. So how you can do this? Customer retention can be done again in different ways. One of these is how I did it again with a set of tax calculation. So I have some calculations which are like these. I'll bring 1 or 2 and explain through that, right? So new customer, let's have a look at new customers. So again, this is a tax measure. New customer in this case would be a customer. Now there are different ways to find out if the customer is new, but one of the way to find out if the customer is new is to check if that customer have made all of their payments, all of their purchases from you in a certain period of time. For example, let's say I consider a 2-month period or a year period. In this case, I think we considered a yearly period. I would say in a yearly period, how much this customer purchased from me. Let's say purchased $20. In total, how much this customer purchased from me? Purchased $30. So this means that this customer is not a new customer, right? Because probably have purchased that other $10 somewhere else and only $20 this year, right? So one way to find out this customer is new customer is that if the total purchase of that customer is matching the purchase of that customer within that period, right? So in my case, I actually did that way. I said, give me, again, there are some calculations here, some variables and things like that. I'm skipping a lot of details now. I'm calculating the sales in the last year. This part of the code is calculating like a filter, give me a year before the current date the current date that we used the selected value function previously for that, we used another approach here. It's kind of the same, but it's just a different approach. We used max of that date. So give me all the period from this selected date, like from 1 year before that until then, and then calculate the sales for that, right? And I would call it sales until now, right? I would also calculate all the sales, which is basically the running total of sales, all the sales until now, right? This is not for last year only, this is for all the time. And this is a simple running total calculation, just to show you what that running total calculation is. I can bring that here as well. You can easily even use the running total quick measure calculation for that. So something like that, nothing really complicated. Now back to my calculation. So I actually create a virtual customer table. Again, I created a virtual table index. It's really important technique that you can use to virtually create dynamic tables. So I've created a customer table with a couple of extra columns with the sales until now, with the running total sales, and that is the whole important part of this. The rest would be from that table, from that customer table, I'm filtering and getting only those records that their running total sales matches the sales until now. Like they've purchased $20 and that $20 is the entire purchase they have made. And of course the sales is more than 0 because there won't be a point showing those if there's no sales, right? The rest, those if then kind of expressions are just to make sure that I'm showing that in the valid range like what we did in the previous one. Now this is for the new customers. For the lost customers, there is only one single difference. That customer table is exactly the same table. I've created that. The only difference is this filter. In this filter, I said that if there is a running total sales, but there is no sales in the last period, sales until now is actually sales last period, right? There is no sales in the last period, but there was a running total sales. This is a lost customer. Or returning customer is saying that if the sales until now, which is the sales of this last period, is less than running total sales, that means this customer purchased $20, but in total this customer purchased $30. So that means this customer is returning, actually previously purchased $10 before, right? So all of these calculations end up with having something like this, which I can actually see how many customers I have lost or new gained or retaining, which is retention, customer retention, for every single period. This might be month, this might be day, year, whatever. The only thing is that this period that all of my calculation is based on, this is not a dynamic period, it is always 1 year period. Now sometimes you want to make it dynamic, like what I have showed you here. Like I changed that period, and that period change is actually changing the fact that it's not 1 year anymore. This is going to be a little bit different. So for that, I did it this way. I actually created some calculation. These are flexible, and the way that they are flexible is that I used a parameter. In my parameter, let me first show you my parameter. In my parameter, this is a pattern called parameter table. So within a pattern, I'm using another pattern. It is a pattern called parameter table pattern. The way you can use it is you can go and create a new what if parameter. I've created the parameter that has values for month, like 1, 2, 3, 4. You can create like something like this, saying that I want from 1 to 20, whatever, increment one at a time. Default, let's say, is 4 months. So I've created something like that. And that come normally with a measure saying that this is the value selected. Then I use that in my calculation. So for my new customers calculation, this is changed. All of that is the same. The only part that has changed is here. instead of saying go to -1 year, which is 1 year back, I'm saying that -1, the number of periods I have, that's positive, that is why I have -1. So if I have like 4 months, 4 in there, that means -4 months. So from that given date, like in the last 4 months, if there's any sales or not, or if this is 5 in the last 5 months, or in the last 10 months. And this is the calculation I've done in all of those, in lost customer, new customer, and returning customer. So nothing really complicated. It is just the same thing. The difference is that I have this slicer, which I can change it, and based on the change of the slicer, you should see these values are changing. Okay. Now I have also visualized that in a chart. Here you can see that when I change it, these values are changing. So this is some of the calculations we can do in subscription pattern. It's not just these, of course. There are some other things you can add into this, such as your customer lifetime value, and some other stuff like the amount of time this have been opened and things like that. But this gives you an understanding of how these are done. Normally they are with combination of how tables are placed together, the relationship. For example, for that DAX calculation, it was important that we do not have the relationship. And also some of the places you might need to use some DAX calculation and the way that you use it. I have quite a lot of different design patterns explained in blogs and videos. These are links to those. Go ahead and check those. There is normally explanation, the video, and the file that you can download them all and learn about these. These slides you can download it, by the way, from the from where we have these slides uploaded in the system, of course. A special thanks to our sponsors, and if you have any questions, feel free to let me know. I'm online and I'm happy to take any of your questions. Thank you.